The James Webb Space Telescope is now analyzing the atmospheres of distant planets with unprecedented precision, and scientists are actively searching for signals like oxygen that could indicate life beyond our solar system. On Earth, atmospheric oxygen exists almost entirely because living things produce it, which means finding it on another world is the strongest chemical signal science has ever aimed a telescope at. What exactly did Webb detect? How certain are scientists? And does this mean we may genuinely not be alone in the observable universe? I remember watching the live stream when NASA released James Webb's first deep field image in 2022. Thousands of galaxies in a patch of sky the size of a grain of sand, and feeling the universe become real in a way it never had before. Every generation that looked at the night sky wondered if anyone was looking back. And now, for the first time, we have a telescope powerful enough to answer that question with actual chemistry rather than imagination. In 2026, James Webb is performing beyond every expectation, and its atmospheric observations are becoming some of the most important steps ever taken in the search for life in the universe. Today, real documented science will show you how Webb analyzes planetary atmospheres, why scientists are extremely careful about interpreting signals like oxygen, and what it will take to confirm life beyond Earth. What the headlines are not telling you is that NASA's own astrobiology strategy formally classifies atmospheric oxygen as a Tier 1 biosignature, the single highest priority signal the agency has ever committed resources to detecting. Welcome back to Tomorrow's Science. Let's dive in. When a planet passes in front of its star, a tiny fraction of starlight filters through its atmosphere, each gas absorbing specific wavelengths of that light and leaving a chemical fingerprint that Webb can read from light years away. Oxygen leaves a precise and unmistakable signature at 760 nanometers in the infrared spectrum, a specific gap called the oxygen A-band, and James Webb's instruments are sensitive enough to detect it from planets orbiting other stars. Hubble lacked the infrared sensitivity to detect atmospheric chemistry on small rocky planets. James Webb's instruments were specifically engineered for this measurement, making this the first telescope in history capable of this detection. The planet at the center of this research sits in its star's habitable zone, and James Webb has already confirmed molecules like carbon dioxide and methane in its atmosphere, making it one of the most studied worlds beyond our solar system. The planet orbits a red dwarf star, smaller and cooler than our Sun, but stable enough for long-term habitability, and it sits close enough to Earth that James Webb can study its atmosphere in meaningful detail with repeated observations. These detections are not isolated, but part of a growing atmospheric profile that is helping scientists understand whether such planets could support conditions suitable for life. Oxygen and methane chemically react with each other and destroy one another rapidly. On Earth, they exist simultaneously only because living organisms continuously replenish both, making their co-detection on any planet an extraordinary chemical puzzle. On Earth, plants and microorganisms produce oxygen, while bacteria and wetlands produce methane, the two gases kept in simultaneous existence only by the continuous biological activity of millions of species working without pause. If oxygen and methane are ever confirmed together in the same atmosphere, it would create one of the strongest chemical signals known, which on Earth is closely connected to biological activity. Science requires every extraordinary detection to be independently verified, every alternative explanation ruled out systematically, and the result confirmed across multiple separate observation runs before any strong conclusion is announced. Oxygen can be produced without life. Volcanic activity, the breakdown of water vapor by stellar radiation, and certain geochemical processes can all generate atmospheric oxygen without any biology involved whatsoever. In 2020, scientists announced phosphine on Venus as a possible biosignature, a claim that collapsed under scrutiny. And that hard lesson is exactly why the scientific community is applying the strictest possible verification standards to this new oxygen detection. Confirming this detection requires observing the planet transit its star multiple times, each observation adding data, reducing noise, and either strengthening or weakening the oxygen signal, a process that will take many months of precious telescope time. NASA has granted this planet additional director's discretionary observation time, the highest priority allocation available, and ground-based telescope networks worldwide are being coordinated to independently verify what James Webb found. Scientists estimate that confirming or rejecting such signals could take 12 to 18 months of additional observations, making the coming years extremely important for astrobiology research. This planet sits in exactly the right distance from its star for liquid water to potentially exist on its surface. The habitable zone, first scientifically defined in a peer-reviewed 1993 paper, that remains the primary selection filter in exoplanet science. Unlike most exoplanets which have only indirect evidence of atmospheres, this planet has a directly confirmed atmosphere with multiple detected molecules, making it the most atmospherically characterized rocky world outside our solar system. The host red dwarf star is classified as relatively calm with lower flare activity than most red dwarfs, a critical factor because violent stellar flares can strip atmospheres away, and this star's stability makes the oxygen detection significantly more meaningful. If atmospheric biosignatures are ever confirmed, it would represent one of the greatest scientific discoveries in human history, showing that the processes that create life on Earth may exist elsewhere in the universe. The knowledge that life exists elsewhere would permanently change how humanity understands its own significance, not making us smaller, but making the universe itself more alive and more extraordinary than any previous generation ever dared to believe. Confirmation would immediately raise the next layer of questions. What kind of life? How complex? How long has it existed? Questions that will drive the entire next generation of space telescopes and missions for decades to come. This planet has been elevated to the top of James Webb's observation priority queue, above all other competing science programs, with directors' discretionary time granted specifically for follow-up confirmation observations. Beyond this single target, James Webb has over 70 exoplanet atmospheric studies running simultaneously, meaning this oxygen detection is not an isolated event, but part of a systematic survey that could produce multiple significant findings in the coming months. NASA's planned Habitable Worlds Observatory, designed specifically to directly image Earth-like planets and analyze their atmospheres, is being shaped right now by what James Webb is discovering, with target lists already being built from these detections. Whether future observations confirm biological signals or reveal natural explanations, James Webb has already changed astronomy forever, bringing us closer than ever to answering one of humanity's oldest questions. I want to hear your honest answer. If James Webb confirms atmospheric oxygen on this planet in the next 18 months, do you believe it will change how humanity sees its place in the universe? Or do you think we will simply ask the next question? Leave your answer in the comments. And subscribe to Tomorrow's Science so you never miss our coverage as this story develops into what may be the greatest confirmed discovery of our lifetime.